For this lesson, I'd like to define what it means to be a rational exponent. So starting here, if we have x to the power of 1 over n, which is a rational number or a fraction, we define that to be the nth root of x. So here I have a few values listed. Let's compute these and see what they're equal to, starting with 25 to the 1/2 power. According to this definition, that is the square root of 25. And you can put the 2 if you would like, but it's customary when dealing with a square root. You just write the symbol, the radical symbol with no 2. And the square root of 25 is 5. So if you have 25 to the 1/2 power, that really means take the square root, and I know the answer is equal to 5. But really you could have any fraction of 1 over n, like a third. What is 8 to the 1/3 power? So this means the cube root of 8. And here writing the 3 is important because you're saying it's not the square root, but it's the cube root. You know, you could do this right in your calculator. I have it over here. Mine's all ready to go. Where if I take the cube root of 8, my answer is 2. So just comparing these two, if you were to square 5, it gives you 25. And so going in this direction reverses that. Likewise, if you were to cube 2, it would give you 8. That's why the cube root of 8 is 2. And the nice thing for cube roots or odd power roots is that they work for negative numbers. Like over here, what is the cube root of negative 27? The difference is your answer will be negative. And okay, the cube root of 27 is 3. And the reason for this is if you cube a negative and 3, you get a negative 27 back. So maybe just to expand on this definition, the reason the fraction refers to a root is because of the following. 25 is the same thing as 5 squared. And if you raise that to the 1/2 power, we have a rule for exponents that says you multiply these two numbers together. So that would be 2 times 1/2, which is equal to 1. And basically, it makes our answers match up if this rule of exponents applies. Does this work for 8 and negative 27? So it should. Like over here, I know, or I knew ahead of time, that 8 is the same thing as 2 cubed. And if you raise that to the 1/3 power, we want 3 times 1/3 to equal 1, which gives us an answer of 2. So again, our answers are matching up. And it'll work for negative values as well. I have to be careful with parentheses here, but I know that negative 27 is negative 3 cubed. And if I raise that whole thing to the 1/3 power, I'm again multiplying the 3 and the 1/3, and it gives me negative 3 left over as my answer. So this is the reason for our definition. It makes the rules of exponents work for fractions too, where you just multiply these two numbers together. For the last two numbers that appear here, it's a couple of things to look out for. It's possible that you might get an error message if you type something like this into your calculator. So I'm going to type in negative 25 to the 1/2 power, and it says error. So I'll write that over here. Just basically means there is no answer, but this makes sense. This means square root, and you can't take the square root of a negative number. In fact, this would happen for any even number in this fraction, like a 4th root or a 6th root. In this instance, negative numbers don't work. They will only work for an odd powered root, like a 3rd or a 5th or something like that. So you're not always going to get an answer, but that's okay. It would show up in your calculator. Also, over here, I have 5 to the 1/2 power. And it might be that you're unable to compute the answer like we did up here. So if I type this one, 5 to the 1/2, okay, this gives me a decimal that goes on forever. So over here, this is I get 236067977, and then it stops, presumably because it ran out of places to put values in the decimal expansion. But the point of this is sometimes you can't get a nice number for your answer. And when you go to your calculator, the best you could do is get a decimal approximation for it. But that is it for at least defining fractions of the form 1 over n. By using our previous definition, it is a fact that all of our rules of exponents hold for fractions, so not just integers. In example 1, I'd like to practice this idea where we should know how to solve this pretty easily. And then this piece down here is really similar, but the only difference is I have a power of 1/2 instead of an integer. And we'll see how these two examples compare. Let's start with this one. 4x to the 8th y to the negative 6 all squared. The rule of exponents that we have is this 2 gets multiplied to every single exponent that appears within the parentheses. I want to be a little bit careful here. 4 is really to the first power. I have x to the 8th and y to the negative 6th. And then I have this power of 2. All I wanted to do is put that exponent of 1 on the 4 to indicate that this 2 really gets multiplied to this 1. All of that being said, if I square this out, I get 4 squared, I get x to the 16th power, and I also get y to the negative 12th power. I can further simplify because, well, 4 squared itself is 16. I can't do anything with x to the 16th power, but if I have a negative exponent, that means I can place that variable in a denominator, making this my final answer. So these are rules that we already have up to this point. Essentially, take this and multiply it to every single exponent. Okay, this concept should hold here. Instead of a 2, I have a 1/2. The only difference is I'm going to take this 1/2 and multiply it to every single exponent. Let's see how that changes things. So I'm going to start by rewriting the problem. This is really 4 to the first, x to the 8th, and y to the negative 6, all to the 1/2. If I multiply that 1/2 to every single exponent, I get 4 to the 1/2. The reason for that is 1/2 times 1 is a half. My next term would be x to the power of 1/2 times 8, which is 4. And lastly, I get y. It's 1/2 times negative 6. The product of those two numbers is negative 3. So if you'll notice, all we did is just take half of every single exponent that appeared over here. The last thing to do to simplify this is, well, okay, here we have 4 to the 1/2 power. I know that's the square root of 4, so I'll put that in here. I have x to the 4th, and oh, okay, all right, we have this y to a negative number, so I can put it in a denominator. And then maybe one last step would be, well, I know the square root of 4 is 2. So I get 2 x to the 4th over y cubed. And this is my final answer. All right, we can try this again. Again, I want to simplify this expression using our properties of exponents, which do hold for fractions. All right, everything is being multiplied together here. I think what I'm going to do as my first step is simply write the x's next to each other and the y's next to each other. So this is x to the 1/2 times x to the 2/7 times y to the 2/3 times y to the negative 5/6. So I'm doing this because, all right, the bases here are the same and the bases here are the same. And we have a rule that says if the bases are the same, we can add the exponents together. So the only difference is here we're going to add fractions. This becomes, well, we really have x to the, it's 1/2 plus 2/7. And for the y's, it's y to the 2/3 plus a negative 5/6. The last thing to do would be to simplify our answers by adding a 1/2 and 2/7 and then taking 2/3 and subtracting 5/6. So I'm just going to do that part separately. So, what is a 1/2 plus 2/7? I need a common denominator of 14, which means I'm multiplying the first fraction by 7 and the second fraction by 2. And if I add these together, I get 11/14. So I'm going to replace this number with 11/14. That's x to the power of 11 over 14. I want to do the same thing with the y's, where, all right, here I have 2/3 minus 5/6. I need a common denominator in order to subtract these two fractions, and my common denominator is going to be 6. I do not have to do anything to the second fraction, but I do have to multiply the first fraction by 2. So this is really 4/6 minus 5/6, and that's negative 1/6. That goes here. And I'm almost done with simplifying this expression. I just see I have a negative exponent. Anytime that you have a negative exponent, in this case, I can put y in the denominator. So I have x to the 11/14 divided by y to the 1/6 power. And that's my final answer. All right, one last one here with just applying our rules of exponents now with fractions. Here I have x to the 3/5 times quantity x cubed plus 4x. So what we'll have here is just using our distributive property, where x to the 3/2 is going to be multiplied to both of these terms, which gives us x to the 3/5 times x cubed plus x to the 3/5 times 4x, and I'll put a 1 in that exponent. Not too much to really simplify up to this point before dealing with the exponents. Maybe I'll rewrite this as x to the 3/5 times x cubed, and then I'll write this so I have the 4 out front, and then I have x to the 3/5 times x to the first power. And essentially we're doing what we did in the previous example, where, I just add the exponents. This is x to the 3/5 plus, well, it's really 3/1, and that's plus 4x to the, here we have 3/5 plus 1/1. So again, all I'm doing is taking this exponent, that's 3/5 plus 3/1, and combining it into one fraction. My common denominator is 5, so I'm multiplying that second fraction by 5, that's 15/5. And if I add my numerators, I have 18/5, which can't be simplified. So I'll go ahead and do the same thing for this one over here, where I have 3/5 plus 1/1. Again, a common denominator of 5 means I'm multiplying the second fraction by 5/5. And this is 8/5. This makes the final answer x to the 18/5 plus 4 times x to the 8/5, and that is it.